Hi, this is the part third of analyzing pattern, and in this part we will discuss the spatial autocorrelation. And as you know, we have already discussed about the high and low clustering in part two. So this part is important from the viewpoint of comparing the results, that how spatial autocorrelation is different from high and low clustering. So this is important video. And down something is about me. I'm Dr. Zubairul Islam. Working in the Department of Geography in Adigrad University. So this is the formula given for spatial autocorrelation, global Morans I statistics. So for this, the tool measures spatial autocorrelation based on both features location and feature values simultaneously. So given a set of features and an associated attribute, it evaluates whether the pattern expressed is clustered, dispersed, or random. The tool calculates the Moran I index value and both a z-score and p-value to evaluate the significance of that index. So p-values are numerical approximations of the area under the curve for known distribution limited by the test statistic. So if you will see the formula here, in this formula, it is different from earlier means video number two's formula. Where is the difference here? As you can see in this formula, zi is the deviation of an attribute. So here zi is the deviation of an attribute for the feature I from its mean, and wij is the spatial weight between feature I and j. N is equal to the total number of features, and here the s S0 is the aggregate of all the spatial weights. So this is the difference in the formula, and the important thing is, so there is a, to understand that there is a change in the statistics if we compare high and low clustering and the spatial autocorrelation. So statistics is different, so result will also be different, and the interpretation of the results of both the test for a pattern will be different. So we will go through the software and we will see the result, and thereafter we will compare both the results, and then it will be very much clear. ArcMap is open here, and on the left side is my data, and right hand side is the R toolbox. I'm using the same data, and I will use the same attribute which I have used in video number 2, and that attribute is the temperature data at Kabyle level. So we will see the temperature at Kabyle level, what is the pattern, and here we will use the spatial autocorrelation. I will click spatial autocorrelation, and I will give the feature class, that is here, and I will give the attribute is temperature, the same attribute. Yes, I want this report. And conceptualization of a spatial relationship is very important. I will advise you to practice with all methods of the spatial relationships to understand the difference. If you will choose another method, then what will be the difference? So I am using the same inverse distance which I have used earlier in video number 2. Distance method is Euclidean distance. Standardization is none here, and distance band you can give, so it can cover it can cover all surrounding neighborhood of any Kabyle. you can give 20 kilometers something or 30 kilometers, but I didn't give, so leave it. It will take, the software will take itself. And weight matrix file, this file you can generate with the help of modeling a spatial relationship, which I have discussed before. So if you are generating a spatial weight matrix, then maybe it can give you better results, but you have to compare and you have to see the results. And now this time let's work with inverse distance, and the report will be generated here. Then do it OK. So my result is ready, and as you can see here in the geoprocessing in results, and this is the spatial autocorrelation, and this is the message. Because I have opted the option to generate the report, and the location of the report is this C user Argos documents ArcGIS, and like this, so I can go direct to that folder, and here this is my result, that is Moran I result. Open with Google Chrome, and this is my result here. As you can notice, now the Z score is 38.77. Earlier I think it was -11. So what is the difference? What spatial autocorrelation report is giving us the information? What information it is giving us? So before I go for comparison, just see, have a look. P-value, that is if Z score is 38.77, so the p-value will lie in this red, the last part, that is 0.01. It means less than 1%, because it is very far from 2.58 also. So you are much confident, very much confident that uh, it is highly clustered. How much you are confident? Because 1%, less than 1%, you are unsure, because this is inferential. This is a part of inferential statistics. Here you can similarly, in as you you can frame the hypothesis in high and low clustering. Similarly, here also you can frame the hypothesis that your distribution, null hypothesis, as your distribution is random. So you are much confident to reject that null hypothesis. No, it is not randomly distributed, and you are more than 99% sure that this cluster is not random, but means this is not that this clustered pattern is not the chance. It is random. It is clustered only. So if you see this color clustered, this box color will give you clear understanding. What understanding? Suppose here this black is showing the high values and white is showing the low values, suppose. So there is high and low values together. These are clustered, means low values are also clustered and high values are also high values are also clustered and low values are also clustered. So here high and low values are not separated but together. So when we will go that comparison, then it will be clear to you. Let me compare previous high and low clustering and spatial autocorrelation reports together, then it will be clear to you. So as you can see, this image is showing the result of high and low clustering and spatial autocorrelation. The result is showing in terms of p-value and z-score. First, you have to focus on this first column. The first column is how the p-value is not statistically significant. So if means in both the cases, this is common in both the cases, that you cannot reject the null hypothesis. It is quite possible that spatial distribution of feature attribute value is the result of random spatial process. Another way, what we can say is the observed spatial pattern of values could well be one of many possible versions of the complete spatial randomness if p-value is not statistically significant. Okay, then you cannot reject your null hypothesis. Your null hypothesis in both the case is that your distribution is random. So if p-value is not statistically significant in both the cases, in high and low clustering, you cannot reject that null hypothesis. But now come to this part. It is important that if p-value is statistically significant and the z-score is positive, z-score is positive. So in case of high and low clustering, if z-score is positive, means your high values are clustered. Your high values are clustered. Okay, your high values will be clustered. So see the result down here. See the result down. So if you will see the down, because your result with high and low clustering was minus 11.280. So you are coming to here that low values in the data set is more spatially clustered. So here z-score is negative. Z-score is negative here. Why I am coming to this third part? Because in my result, this is minus 11. So minus 11, if z-score is negative here, what does it mean? That low values, spatial distribution of low values in the data set is more spatially clustered. So if you have the data of market, any market in a region, in a city also, and you have collected the points with some values, high values and low values, and when you will watch the pattern, so if lower values are clustered, then highly clustered, then your z-score will come as negative. And if your high values are more, means if z-score is positive, then the higher part means high values, something, it may be something related to the retails market, it may be related to the crime, it may be related to any phenomena, natural or cultural. So the z-score, if it is positive, means your high values are clustered. If it is negative, your low values are clustered. This is about high and low clustering results. But in case of spatial autocorrelation, you see, if z-score is positive, then your high and low, both the values are dispersed. Sorry, your both high values and low values are spatially clustered, not dispersed, if z-score is positive. As in my case, in my result, with spatial autocorrelation, I found the result, my result was positive. Okay, that z-score was, I think it was around, z-score is 38. So what does it mean? As you can see this picture, this image inside the square, my high and low values both are clustered. So high values and low values both are clustered. Okay, so if in case my z-score is negative, means high values and low values in the data set is more spatially dispersed. Here and there you can see the disbursement. The black is high and white is low. So high and low values are highly dispersed. So when the values are dispersed, what will be the difference? If the values are clustered, then there is some pattern here. So this dispersed pattern is also a kind of pattern, but if it is clustered, then it will help you to find the explanatory variables, and you can search another variables to explain the relationship with dependent and independent variables. So this is the difference in between high-low clustering and spatial autocorrelation. So you please read this image and think of it, then it will be it will be clear to you, because there are many phenomena may be natural or cultural. Sometimes we are in need of searching that how means the things are distributed high and low values together. Then for that, spatial autocorrelation is the best way to understand the pattern. And if you are interested just to for high values and low values separately, then this high and low clustering is the better way to understand the pattern. Now I'm coming to the software again. So if you see this software, then what I will advise you, whether you are working on high and low clustering, please observe your result with different methods. When you will change the method, then your result will be changed. And what concept of spatial relationship will give you uh, means the result, because if you will see, then you can have a look your data, and this data, when you will go for quantify and you will see the temperature, and you will if you want to see the pattern here, means by looking with some standard deviation, then you may have some idea that what is the the pattern shown here. But this pattern will not give you the figure to reject or support your null hypothesis, means so for that, this analysis is very important. But for visualization, you can classify your data into different classes based on different classifying schemes. So uh, this is enough for this here, and thanks for listening and thanks for watching.